Past 25 years, I have done a lot of interviews on this program, but some really stick with you, and I'm going to play one for you now. Let me take you back to 1995 for a conversation with astronaut Jim Lovell, commander of the ill-fated Apollo 13 mission. The interview took place the week of the 25th anniversary of their historic nail-biting flight and the safe return to the Earth. There are certain dramatic events one remembers very vividly, like remembering where you were when you heard the news about Kennedy or King. Well, for me, Apollo 13 falls into that category too. I'll never forget that night. I was home in bed around 11 o'clock at night, glued to the radio, listening, sleepless, to a heart-pumping drama that would play out all night, awaiting news about the lives of three people I had never even met before, who were cast adrift in a lifeboat with no hope for rescue from any other ship nearby, but with the slim possibility that if they were lucky and smart and sprung no leaks, their lifeboat would find its way home. But first it had to cross a huge ocean, perform in uncharted waters, and survive a fate that no other ship before it had ever faced. This, really, was the stuff of high drama and a throwback to the old days of radio, except that the story was pouring out of my tiny clock radio was real and live and more frightening than anything Hollywood science fiction writers could make up. And now as I sit and talk about it this afternoon, it's hard to believe that that terrifying night occurred 25 years ago. It seems just like yesterday. And the command pilot who had twice attempted to set foot on the moon and who was twice denied the opportunity, Jim Lovell, is my guest here today. He's author of the new book, Lost Moon, The Perilous Voyage of Apollo 13, published by Houghton Mifflin, and the head of Lovell Communications in Horseshoe Bay, Texas. He joins us by phone from his hotel in Costa Mesa, California. Welcome to the program.
Good morning, Ira. How are you?
Fine.
Well, good afternoon now.
Well, wherever you are, you know what Einstein says. What are you up to these days?
Well, last night I attended the 25th anniversary of the Apollo 13 incident, and we celebrated it on the 13th, which was what we call Boom Day.
Is there a sort of a black humor about this now?
Well, you have to have a little humor, in tight situations.
You weren't very humorous in those back 25 years ago on that night, were you?
No, I was a little apprehensive, a little frustrated, just about everything.
Did you really, in your heart of hearts, believe you were going to get out of that situation?
Well, when the explosion first occurred, we didn't know the severity of it because we were losing fuel cells, but one fuel cell would have been sufficient for us to get home. And then we saw the oxygen going out, then we knew that the third fuel cell would die, and then pretty soon the whole command module would collapse on us. And that's when we got to be starting to worry about whether we would ever get home again.
You've said that if the explosion had happened earlier or later, you and the crew would not have survived. Why is that?
That's true. If the explosion occurred just after we committed ourselves to leave the Earth and go to the moon, we would not have had enough battery power in the lunar module to make that transit all the way around the moon, and we could not turn back because we had no ability to fire our command module's engines because we lost all the electrical power. Had this explosion occurred after we were orbiting the moon and we had detached to go down to the lunar surface, we would not have had enough fuel in the lunar module once we got back up to get out of lunar orbit and propel ourselves back to the Earth.
So that was really the only lucky part of the mission.
Yes, it was very, very fortunate that if we were going to have an explosion, to have it at that time. Three
big men were able to squeeze into a little lunar module equipped for two people that was only designed for two people for 2 days. The story of how you got enough air to breathe and water to and food to live on is fascinating. What did you have to do to turn that into a lifeboat?
Well, we had to do several things. First of all, we had to use its propulsion system to reestablish the proper course on the way home. Then we had to use the same propulsion system to speed up our return home because, as you mentioned, that vehicle was designed only for 45 hours and two people. And as I looked around, I counted three. And I didn't want to be left behind, so I thought we better stretch it out. And also, we had to use his guidance system for a while, so we had to transfer all that guidance information from the dying command module into the lunar module. And since the temperature was dropping anyway, it was kind of crowded, but our body warmth kept us comfortable just a little bit.
You know, the space program of the last 40 years is always filled with defining moments when something happens and a technician or an engineer or somebody makes that incredible decision about to go or not to go or to do something. What was that moment on your flight?
Well, there were several moments because we had crises to overcome all the way home. I think the first critical decision was the crew's decision to get into the lunar module, which came quite a bit earlier than when the ground finally realized that we did have all these things going wrong with us. And we got in there and turned on those systems with just enough time to transfer the guidance information. That was the first critical. The second one was a ground decision that says, let's get them back on that free return course again, and they did that. The third one was a decision that was not a hard one to decide, but Hayes came up and said, we don't have enough battery power in the lunar module to get home, and the ground agreed at the same time, and then they said they think we have a solution, and that was their decision to burn the engine for a second time for a long period of time after we passed the back of the moon. And, of course, the final decision was to, again, readjust our course, which was necessary, but we had to do that by the seat of the pants because we had turned off all those exotic electronic devices to help us navigate. See, we had our navigational equipment in the command module. We had very similar equipment in the lunar module. And we held those two, mated together all the way home. But after we lit our engine for the second time and had it on for about 4.5 minutes, then we shut everything down to save electrical power so that we'd have enough power to keep control of the vehicle all the way home. And when we did that, we had to turn off all the exotic electronic navigational equipment, so we lost in the memory of the computer the position of the navigable stars, and we turned off the guidance system, so the platform went down. The autopilot wouldn't work anymore, and we thought that we could just coast back on what we call the free return course until we found out that we had to make another adjustment. So we did lose those equipments as far as being able to use them, but they were still in the lunar module.
There were a couple of times in the mission where your microphones were on and you didn't know it, and you said some things that you may have later regretted, but probably not anymore. But there was one interesting comment that you said to Fred Hayes. He said, I'm afraid this is going to be the last moon mission for a long time. That didn't pan out that way, did it?
Oh, no. I said that, well, first of all, I thought I was on what we called Vox, voice activate, or push to talk.
Right.
In other words, I thought I'd have to push the button before anything would go outside of the spacecraft. And so I was just talking to Fred. We were looking at the moon just as we got in there and said that this is good. I said, take a good look at the moon, Fred. It's going to be a long time before anybody gets back here.
Why did you say that?
Because that's exactly what I thought at the time.
Yeah. Well, I guess that's the
we had no propulsion. We had no electricity. We had no, nothing. And I knew that NASA was going to have to do some real great research. And, of course, there was still a great chance that we'd never get back alive.
And you were able to, at one point, to turn around and actually see the exploded oxygen tank on the side of the service module. And your reaction must have been incredible about the amount of damage you could see.
Well, just before we hit the Earth's atmosphere on the way home, we jettisoned the service module. We maneuvered slightly so that as it tumbled by, hopefully we could take some pictures, which that occurred. We took some pictures and saw the whole side of the spacecraft blown off.
And how long did it take for them to find out what really went wrong?
It took about 3 months of intensive investigation after the splashdown. We looked at the history of the spacecraft's building. We went back and looked at the telemetry. We reproduced in laboratories what we thought went wrong. We had a pretty good idea, fairly shortly, but we had to reproduce the situation by testing, and then we finally got the answer. Most accidents in aircraft are caused by a series of incidents that either overcome the pilot and or the airplane. This was a classic example of that situation. The accident was set up 5 years before we took off. When NASA at that time informed all the contractors to make the electrical equipment in the spacecraft compatible with the high voltage, which I think was about 65 volt DC voltage at Cape Kennedy, even though the spacecraft flew with only 28 volt DC power. And the main reason was they could do some testing a lot quicker at the Cape with the higher voltage. Everybody did, except the fellow who built the heater system in the oxygen tank. The heater system had a little thermostat to prevent it from getting too hot, but it was compatible with only the 28 volt power and not the higher voltage that was available at the Cape.
You made mention of later on that when they discovered what a good lifeboat that the LAM could be, that it was changed to be able to be on a lifeboat. In what ways was the LEM changed to be more hospitable? Or did you know that it was changed?
Well, I don't think it was changed physically as much as the procedures were incorporated to, in case that this thing happened again.
I see.
That the lunar module could be used as an auxiliary propulsion system or a living space while there was something wrong with the command module.
We're talking this hour about the dangerous mission of Apollo 13. Jim Lovell, the commander of Apollo 13 and an astronaut for many years, and author of the book Lost Moon, The Perilous Voyage of Apollo 13, published by Houghton Mifflin, which has been made into a film starring Tom Hanks. And we'll find out, does Tom Hanks do a good Jim Lovell, Jim?
Oh, yeah, he's an excellent actor.
I didn't ask that question. I said, does he do a good Jim Lovell?
Well, yeah, he spent 4 days down with me, and he got the character down pretty pat. And, he was a closet astronaut. He always wanted to play the part of an astronaut when he got in the acting business, and he finally found the product that he wanted to do.
We'll be back with more of my 1995 conversation with Apollo 13 astronaut James Lovell. Stay with us. This is Science Friday. I'm Ira Flato.
Yeah, that's just what I'm saying. The time to do it is now, guidance.
Flight gun.
Go, guidance.
As long as
You're listening to the audio from Apollo 13 Mission Control in Houston. It was a little after 10 p.m. on the night of April 13, 1970. Over the hours that followed, the ground controllers and the astronauts on board Apollo 13 would have to come up with a way to deal with the damage from an onboard explosion and invent a way to get the crippled spacecraft and its crew back home safely.
all right.
Both have them entered, as well as why don't you tell them what page you want it in the checklist.
Okay.
Flight dummy.
Okay, we got a problem here.
What's the matter with the data you got? Heater current looks normal. Okay.
We got more than a problem.
Okay, listen, you guys. We've lost fuel cell 1 and 2 pressure.
We lost O2 tank 2 pressure.
GNC, you want to look at it?
And temperature.
Okay.
Stand by, they got a problem.
See a hardware restart.
Roger, main B undervolt.
There, guidance? Or ecom?
Negative flight.
O2 tank 2 pressure?
I believe the crew reported it.
We got a main B undervolt.
Okay, flight. We've got some
Main B.
instrumentation flights. Let me add them up.
Raj.
Okay, stand by, 13, we're looking at it.
We may have had an instrumentation problem, flight.
Raj.
Okay, let's get our instrumentation lined up here, you guys.
Go on.
ECS, what do you got? Brownie, you copying us? Air to ground.
Yeah, voltage is,
O2 tank 2.
looking good, Jeff.
Pressure. O2 tank 1 fluctuating.
Coming down on O2 tank.
And we had a pretty large bang associated with the caution and warning there. And as I recall, main B was the one that had a amp spike on it once before.
We're playing excerpts from a 1995 interview with Apollo 13 Commander Jim Lovell. It was the week of the 25th anniversary of the flight, and sure enough, the movie starring Tom Hanks would come out but a few months later.
It hasn't moved.
Is that reflected anywhere?
Negative, no, it's not a
Negative,
signal gate.
Say again, Larry?
No signal gate. No common signal gate.
You and your co-author Jeffrey Kluger have captured some of the real drama that was going on. I mean, the real drama of that first night and subsequent nights that we sat through and listened to, and in particular when it came time where you and your fellow astronauts had to push a button, and it had to be the exact right button, and if you didn't push that button at that moment, it was curtains, the lights were out forever.
Fred and I were in the lunar module, and it would have ruined our whole day if he jettisoned us by mistake.
Well, but and there was one point where one of the astronauts, I guess the commander, the command module astronaut, had to transfer the data from the command module into the lunar module, and they had to do it by voice. And first he had to mentally make calculations, do a little bit of arithmetic, and he so distrusted himself in that time of stress that he wasn't sure what 5 times 3 was. But there must have been, you have to control your fear in that case so much just to understand what 5 times 3 is, that the pressure must have been enormous. Was there,
it was pretty high, yes.
Is there anything in your training that makes you prepared for that moment?
Well, I think the background of all three of us was a big help to this situation, because all three of us were test pilots. All three of us had been in stressful situations before in airplanes that weren't behaving the way they should, and so that familiarity with the stressful environment, I think, really helped us.
All right, we have a lot of people who'd like to ask some questions, so let me go to the phones. 1-800-989-8255. Mike in Coralville, Iowa. Hi, Mike.
Hi, Mr. Lovell. It's a pleasure to talk to you. I'm a very big admirer of yours. My question for you was there any one time that you were completely despaired that you would not get back? And consequently, was there a time when you just came to a realization that you were going to get back?
To answer your first question, there was never a time when we were completely despaired. There was a time of greatest apprehension was when we, shortly after the explosion occurred, and we saw the oxygen escaping from the spacecraft, and we realized that very shortly the command module would die, and we didn't have solutions at that time of how we're going to survive the entire trip back home. The command module was the only thing that had a heat shield.
Oh, yeah.
Let's go now to Barry in Philadelphia. Hi, Barry.
Hi. Thank you very much. I'd like to know what kind of extraterrestrial experiences you gentlemen experienced during this mishap that you had there. And
you mean anything that's strange that we saw that we didn't understand?
Yes.
Well, in the vicinity of the moon, we saw a couple dark shadows or shafts out in the void someplace, which we couldn't quite identify at the time, but we think that they were pieces of debris that had followed us to the moon after the explosion and were blotting out some of the stars. But quite frankly, none of us, none of the astronauts that I know of, believe in what we call so-called UFOs. We all believe that there's life in the universe, intelligent life as we know it, but no foreign visitors around the Earth that come from some other galaxy or some other star system.
Why is it that that NASA could command such great attention from the public and have thousands of reporters in the 60s and the 70s, and now when the shuttle is up and there are astronauts up, you hardly see a mention of it anywhere? Have we really lost the desire for space? Are we jaded? Jim Lovell, what do you think it is?
Well, I think it's a natural tendency. Remember, before the explosion occurred on Apollo 13, and that was 25 years ago, none of the networks carried it. The flight, it was on page 78 of the New York Times about 2 days before the flight. That was the only mention of the flight. We become complacent with spaceflight, and it wasn't until the accident occurred that there was this great interest. It's like, I guess it's like going to an automobile race. Everybody's waiting for the crash on the first curve. And we've had over 60-some shuttle flights now, and they've become very routine. And I look at the shuttle as a proven vehicle, much like an airplane, and the action occurs inside the payload bay, whether we're putting up a new satellite or doing some new experiments in space.
Let's go to the phones to Dan in Norfolk, Virginia. Hi, Dan.
Hi. Mr. Lovell, this is an honor. I'd like to know if you could take the opportunity to tell us about your crewmates, Fred Hayes and the late Jack Swigert.
Yes, I couldn't have picked two better crewmates to weather the accident with me than Jack Swigert and Fred Hayes. Of course, as you know, Jack was not the original command module pilot on this flight. Ken Manley was. And we were exposed to the measles 4 days before we were to take off, and Manley being a bachelor, everybody was sure he was going to come down with him. and so they replaced him with Swankert because Swankert had the measles, and he died unfortunately in early 1983. Fred Hayes is still actively employed with the Grumman Northrop or Marriott. Well, I forget exactly who they went with, but that organization. All three are very competent, and of course, all three are in the book.
All right, thanks for calling, Dan.
Thank you.
Are you the only person who has ever gone to the moon twice and not set foot on it? And is this a great disappointment now as you look back?
Yes, because the Apollo 13 was going to be the peak of my career. I was going to land on the moon. I told everybody, including the press, that this was my last flight. I would go into NASA management or something like that, and I thought I couldn't think of a better way of capping a career. And then, of course, we didn't land. And there was, when the explosion first occurred, of course, there was a lot of frustration because we lost a fuel cell. The mission rules said that we couldn't land without all three fuel cells operating. Mm-hmm. And then, of course, it was one of survival. We forgot about the frustration. Now I look at it sort of wistfully that it was really a sense of a great triumph to take an almost certain catastrophe and then, bring this thing home safely with the help of the ground. And it gives me a little bit of sense of satisfaction to be on a flight that had such an interesting beginning, middle, and ending.
John in Encinitas, California. Hi, John.
Hi, guys. And I'd like to say hi to Jim. It's really incredible to be able to talk to you on the phone. I've been listening to you for about half an hour, and I've got to say you guys were incredibly cool under unbelievable pressure. That's the one thing I'd like to say. But then I have a technical question on top of that.
Go ahead.
You said that the oxygen thermostat, the heater for the oxygen tank, had a 28-volt, I think it was, thermostat on it, or it should have been 65 volts. So I assume that burnt out at some point. But then what happened? I mean, what was the sequence beyond?
Okay, yes, I didn't finish my story there. Right. The second incident occurred. The tank was dropped slightly at the factory years before it was to be put into the service module. They retested it, and then about 6 weeks before takeoff, 4 or 6 weeks, we had a countdown demonstration test where we completely filled the tank full of oxygen, and the tank worked perfectly for everything that it would have to do in flight. After the test, the ground crew went in to remove the oxygen, and when they tried to force it out with the gas, which was the normal procedure, the gas was going out instead of the liquid. So they looked at the schematics of it, and they found out that there was a loose tube, and that might have occurred when they dropped the tank. And so they decided to use the heater system to boil it out. First time they'd ever used it for 8 hours of any spacecraft. They turned it on. The heater system worked. The oxygen started to boil out. The temperature started to rise. As it got to about 80 degrees, the little thermostat started to open up to keep the temperature down. The high voltage welded the contact shut. No safety at all. The temperature kept rising, but no one ever caught the fact that the heater did not turn off at the proper time. It got up to 1,000 degrees Fahrenheit in that tank, damaged all the wiring, and damaged the Teflon covering, but no one ever caught it.
This may be a different day and age, but if this news had come out now about something that happened on the shuttle, there would be tremendous congressional hearings and things like this that would be going on. Now, in those days, I guess they just said, well, there was a chain of mistakes and life goes on.
Well, this was a very fortunate ending to this thing, so therefore it's a lot easier to, to make corrections and go ahead. If we had died on the way home, well, you might never have known what happened. That the thermostat was in all the flights from 8 all the way through 13.
That's very interesting. For me, if the tank rattles, I throw it out. I get a new tank.
Well, we debated about changing tanks, but it just delayed the flight another month. And since the tank worked perfectly for everything that we had to do in flight, and we'd never detank it on the way out to the moon, we saw no problem with it.
But that delay and that month was critical in the period of the space race we were talking about. I mean, there was a tight schedule, and was there sort of the politics of the time that even a month would be too much to delay?
Well, there wasn't much of a race anymore. As you recall, we landed on the moon, and Apollo 8 went around it for the very first time. So, but there was a schedule to keep. But safety was still very, very important, and they looked at everything positively and said the tank was working fine. And they looked at the schematics before we made a decision to go and said, if that little tube is loose, there's no problem. We we don't need that little tube on the flight. We'll just turn the heater on and boil the oxygen out, and then we'll keep going. But no one ever thought that it went up to 1,000 degrees. We only had a temperature gauge outside the test stand that went to 80, which was a big mistake.
I'm Ira Flato, and this is Science Friday from PRI.
All right, let's go to Stevie in Wayland, Mass. Hi, Stevie.
Hi. I was wondering if I could ask Mr. Lovell, what do you think the future holds for the space program?
Well, that is a big question. I think the future holds a space station, probably basically, this is for manned flight, a consortium between Russia, the European Space Agency, Japan, Canada, and the U.S. I think we're finally going to get our act together. It's too bad that we wasted billions on studies that never came to anything. As nations go, I think that we're going to start doing some robotic research on the planets of Mars again, and perhaps make another landing on Venus, with the eventual idea of perhaps a manned Mars flight sometime in the next century.
Martin in Boise, Idaho. Hi, Martin.
Hello. It's an honor to speak to you, Mr. Lovell. One question. I realize that your craft was the best that we could build at the time, but how would it compare by today's standards? Just how primitive was it by today's standards?
Well, it is pretty primitive. We had just one type of computer. It was a hardwired computer. We didn't have such things as floppy disks or all the modern stuff that computers have. I think the shuttle takes off with 5 of them. They're not all talking to each other. We don't go. The instrumentation was rather crude compared to what we have today. The technology today would probably be able to reduce the weight considerably. But as far as the technology was with other stuff in those days, it was highly advanced.
Mm-hmm.
That computer was actually, we call it the 4th astronaut.
All right, Martin.
Okay.
Thanks for calling. There are still 3. There were supposed to be 20 Saturn missions, Saturn V missions, Apollo missions, and they cut them back to 17. And there are 3 Saturn rockets lying around various places around the country. One's at the Cape. One is in Huntsville.
Yes.
And where's the third one? I'm trying to remember.
At Johnson Space Center.
Johnson Space. When you drive by that and you look at that, do you get pangs when you see that there? It gives me pangs, saying, I wish this was standing straight and going someplace, you know?
Well, I think one of the tragedies of our decisions in NASA was not to keep the line of the Saturn V running a little bit longer. And I tell you why. We spent all that money for research and development. It's a beautiful rocket. It puts more into low Earth orbit than the shuttle does. And when the Challenger accident occurred, we had no backup. And we could have had a fairly inexpensive backup if we kept those Saturn V's on the line.
Jim, is there one memory you take away from this more than any other part of the flight? That one thing that stays in your mind?
Well, I'll never forget the sight of the moon as we whipped around it for the very last time. My second flight up there, knowing that I'd never get a third flight. And finally seeing that little triangular mountain that I had named on Apollo 8, Mount Maryland, and it started to disappear in the background. And it was sort of a nostalgic, wistful feeling. At that time, I think we had a fairly decent idea that we might be able to make through this thing okay.
And how many do the astronauts these days? Do they stay in contact with each other from those early years?
Oh yes, we see each other a lot. NASA very nicely invites us down to Houston once a year to brief us on what the latest things that are going on, and then we have things like the anniversaries. I saw Buzz Aldrin and Jack Schmitt last night, and so we get other astronauts together.
All right, Jim Lovell, I'm going to let you go. Thank you very, very much for joining us this hour.
Thanks, Ira.